Start the counter for 23 minutes. All right. Let's go. So here I am back again with the Advent of Code challenge. We're going to do the part 8, the day 8 today. It's long, as you might see already. It will also have part 2. I don't know if we'll have time for part 2, but let's go and jump straight into it. Equipped with a new understanding of teleporter maintenance, you confidently step onto the repaired teleporter pad. You materialize on an unfamiliar teleporter pad and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on the setting up an ambitious Christmas decoration project. Through careful rigging, they have suspended a large number of small electrical junction boxes. Their plan is to connect the junction boxes with long strings of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected with a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that electricity can reach every junction box. Um, the elves are trying to figure out which junction boxes to connect so that electricity can reach every junction box. They even have a list of all of the junction boxes positions in 3D place space. So for example, this is XYZ, right? This list describes the position of 20 junction boxes, one per line. Each position is given as XYZ coordinates. So the first junction box in the list is at da 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 da. This to save on string lights. The elves would like to focus on connecting pairs of junction boxes that are as close together as possible. According to save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible according to straight line distance. Is it this Euclidean distance thing? Was it? Isn't it like yeah? This Euclidean is like this square equals to this square. In this example, the two junction boxes which are closest together are this and this one apparently. By connecting these two junction boxes together, because it can flow between them, they become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now, the two junction boxes which are closest together but aren't already directly connected are this uh, yeah. After connecting them, since this is already connected to okay, so you first found the closest and then this becomes the closest. After connecting them, since it's already connected to another junction box, there is now a single circuit which contains three junction boxes and an additional 17 circuits. The next two junction boxes to connect are that. After connecting them, there is a circuit containing three junction boxes, and circuit containing two junction boxes, the new one, and 15 circuits. The next two junction boxes are da 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 da. Because these two junction boxes were already in the same circuit, nothing happens. Okay. Mm-hmm. Okay. This process continues for a while, and the elves are concerned that they don't have enough extension cables for all these circuits. They would like to know how big the circuits will be. Um, mhm. Okay. After making the 10 shortest connections, there are 11 circuits, one circuit which contains 5 junction boxes, one circuit which contains 4 junction boxes, two circuits contain 2 junction boxes each, and 7 circuits which each with, yeah, they're like the single ones. Multiplying together the size of the three largest circuits, multiplying together the sizes of the three largest circuits produces 40. Your list contains many junction boxes. Connect together the 1000 pairs of junction boxes which are closest together. Afterward, what do you get if you multiply together the sizes of the three largest circuits? Me, no likey. Okay, this is by far the most ambiguous uh, problem. Maybe because of the solution to me. I don't know. So right now we have these coordinates, and we're supposed to go in a fashion that you're always finding the closest ones together. Sorry, um, randomly. Okay, given this list. Um, and once you have found the closest, you'll move on to the next one. You'll move on to the next one. They might be already connected somehow, uh, right? So this circuit also reminds me this like a graph structure, some kind of. Okay. Okay. Um, yeah. Somehow you need to find the straight line distance of them together. Like this one, I don't know. Like shall we have a screenshot and go over it? Basically, interestingly, like, am I supposed to? Am I supposed to do something like this distance? Check this distance, and right, you're going to calculate this all the time for each of them, this Euclidean distances, and you'll do it like for the first element, right, up until checking with this last one, and then you'll go start from here. You'll do this, 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 up until to the end, and in the end you'll go through all of them and you check this one at the full end. So this way you have the distances. You can calculate it at once. The time complexity will be a bit high, one square, but you in the end store the distances in a data structure like a list, and you can put the distances there is a first item of the tuple, right? For example, you can put it like this. The distance is 25. The position, this is 0 and this is 1, right? So 0 to 1. Oh, what happened there? Okay, 0 to 1. And then you can put them all into a list, and then you can sort it with respect to the first element, and it will be like in the ascending order, right? And from there on you can go each one. You can check, okay, this one, these two belongs together, so you can say yeah, you need to somehow group them. You need to store this grouping information. I don't know how would you store that? Like, I don't know, like, perhaps you can say, you can name them like starting from 0, right? You can say 0 belongs to group 0, 1 belongs to group 0, and once we have a new one here, such as, let's say it was 30, and it was 3 2 2 3, and the next one is 40 and it's 3 0, right? So if we were to go through them, we'll process this one, and we're going to say, okay, does 2 and 3 exist in our scene list? No. Okay, then we can say, you can increase the ID of them. We can say, okay, it's 1. We can say, okay, 3 happens 1. Not happens 1, but like in the group 1, right? This was group 0, and then we're processing this one, 40, 3 0. So I see like 3 exists here, 0 exists here. Oh, we have a chance to connect them together, right? We can then say, basically, we need to find like, okay, we will connect them. They have different numbers right now. We can choose one of them. Let's say we choose 0, and then we're going to go over this dictionary. We'll look for the 0 ones. Sorry, yeah, we can choose to transform 1 to zeros. We will look through the ones with the value 1. So this is this one, and then we're going to set this thing to 0. This will be set to 0. The question was, what do you get if you multiply together the sizes of the 3 largest circuits? Okay, it only wants the top 3 ones. Yeah. I think this will be a very, 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 very ugly implementation if I were to go with this approach. I will go through each line here, right? Each Euclidean distance, um, the index of these things here, right? Coordinations. Basically, this is one position. This represents the index of the position 1, right? Represents the index of the position 2, and that kind of stuff. We'll go over it and we'll update this dictionary basically along the way. The bad thing about it is it will potentially be on, because no, on square as well here, because for each one we'll go over the dictionary values and check. Okay, for example, this one, right? We see 3 here, we see 0 here. We decide to choose the like we check basically. One has 1, the other one has 0. We check, okay, which one is the smallest 0. Okay, then let's scan the whole dictionary and change it to 0. Okay, and if we were to have 55, 3 and 5, we'll what we will do, we will add a new thing here. 5 will belong to the group 0. So yeah, I think we will go through like this, and in the case of both of them being in the same group, we will skip, right? So there's how many cases do we have? We have the first case is no circuitry in between. 2 is one of them is in circuit, is in a circuit, the other one not. Both of them are in the same circuit. Both of them are in separate circuits. No circuitry for both. Yeah, I think these are only the 4 conditions, if I'm not mistaken. Once you have this, you're going to, if you don't see the circuitry for both, you're going to check the latest group index, increase by 1, assign to both, put them to dictionary. If one of them is in circuit, the other one is not, read the group index of the one with the circuit. Basically, it's a circuit index, right? Add the other one with the group index. Both of them are in the same circuit. Nothing. Both of them in separate circuits. Merge. So it will happen like choose the smaller group index, scan over the dictionary items, and replace the ones with the bigger index with the smaller index, right? So we'll be, yeah, something like that. So can I just have it here? I think this will be the solution. I have a very limited time available right now, but let's go ahead and implement it real quick. I have a feeling that will not perform well, the performance wise. I believe but hopefully we'll be able to submit. Okay, that's our hope. So this is the test one. I think I skipped some of the. Okay, that's good. So let's go. Input txt is this one. And then we'll have the part1py. We'll basically read positions, right? And it will q8 input test txt. We'll have the positions list. Okay, it will be the read positions. Go away, please. Path string list of tuple int basically xyz, and with open path as f for line in f line.strip line split with input test yeah, split with this, and then tuple, make it a tuple, but I want to cast it to integer, perhaps something like this, for a position string in here, integer position string, something like this. I don't know. I'm making this thing up right now. If I were to print positions, what will happen? Okay, seems to be fine. Remind me in 10 minutes. No, start wait. Start the counter for 10 minutes. Okay. Alright, so the next thing is the data structure that we've planned, right? It will be a list. The first position will be the Euclidean distance. Yeah, just use the position. I don't know. Position 1, position 2. Okay, it will be a tuple. So it will be quite a different thing. But we can say distances, alright? So we'll have the distances. Let's define it. So it will be a list of tuples. The first one will be the integer, the distance. Then the position will be also again a tuple of int. And the next one will be the identical one, right? And then we will close and then close the list, and it will start like this. and then we'll fill calculate distances. We can call we can pass the distances here. I think it's okay. We'll give the positions, and let's print distances right now. We'll fill it in place there. Calculate distances accepts the distances thingy. Maybe we don't really need that. Maybe we can say, okay, we'll have this distances here in this. I think you can also put it here, something like this. Should do return none. I don't know. Distances. So it will only have the positions, which is this information. The type hinting wise, so it's getting a lot of ugly code, but yeah. So returns this. Let's get rid of this. Let's get rid of this. Distances. Let's go none. That's right, because we didn't calculate the distances yet. So positions or positions. Okay. All right. So we'll go over the. I don't know. Like we'll iterate, right? We'll go through like for position 1, for I in range, length of, is it positions? Yes, positions. For j in range, length of from I plus 1 to len positions. Positions I, positions j, calculate what was the Euclid? Maybe we can call it calculate distance. Okay, I think it's acceptable. All right, so you'll have put the positions I here, positions j, and once you have this calculation, so this will be the distance, and you're going to put it into the resulting array, and you result that append this tuple of distance, position, yes, positions I, positions j. Okay, so I think so, and then in the end you return the result. The calculate distance we will go with right now. If we were to return them all in, so it will have position 1, it's this, position 2 is this, returns an integer, return 1 all the time, and let's print. So as you can see, the structure seems correct to me. I don't see any red flags. It looks good, right? To this, yeah. So right now, let's calculate the distance between them. How does it work in 3D dimensions again? I have an idea. Is it I don't know. Does it also shows that like that? I mean, should I calculate it? like Python math 3D distance. I don't know. Is there like something for that? Okay. Yeah, we're summing up. Yeah, this is it. Oh, we have it. I mean, let me use that. I think that's okay. That's acceptable. Math.dist. Position 1, position 2. Should return a float, I guess. Yes. Okay, let's return float. I think that's okay. That's like will bring the best thing for us. So this was the distance, right? Okay, let's go. So we have, for example, this is one of them. This is the other thing. That's good. Distances sort, please. So this is the biggest one, the longest distance, and yeah, here. Is it the correct one? 62, 817, 812. Yeah, and okay, yeah. And then the next one is this one again, and this 431,825, 431,825,988. Okay, I think so far so good. We've calculated distances, and we've sorted them, and from there on now we're going to apply our cases. What do we have? What's the stateful thing? We have like last group index, or like last latest circuitry index. Let's start it with 0, -1, so that we can use 0 in the first one. And also we have a dictionary. Dictionary stores the positions and their relevant group circuitry indexes. So position to circuitry indices. I don't know, it's a very long one, but okay, let me specify that. So it's the first one is a tuple. I think it should be okay as a tuple. You can't put a list, but you can put a tuple, and the is a key. Start a counter for 10 minutes. I have to do it. And the index, right? So it will be an integer. We'll start with this, okay? And we'll go through each of the distances here for distance in distances, but not a lot. I think the first 100 for 1,000 pairs of junction boxes. When you connect together okay, but I think nothing happens if they're on. So you can't just put 1,000. You just need to go through and check, increase it manually. So you can say when you connect together, paired count. Okay. While paired counter is less than 1,000, let's go. And in the end, we want to also like make sure that we are increasing the paired counter. So, and also you also need to check like if you also need to check like what was the thing, the index, like distance index. Okay, and distance index is less than the length of distances. Okay, probably it will not fail there, but in the test case I think it will fail. But we'll go through in this one, right? We don't have 1000 entries there, but here we'll basically have our distance object here at our hands. Oh, basically we don't care about it. Actually, we only care about position 1, position 2 from the distance says distance index. And then you will check what were the cases. Both not circuited, both single. It is true when position 1 not in positions to circuitry indices, and position 2 not in positions to circuitry indices. One single, one circuited. Position 1 not in position, okay, and position 2 in positions to circuitry indices. Okay, so that's one opportunity. And or position 2 not in there, or like we can keep the order there. So if it's position 1 is there but position 2 not in there. Okay, so that's the one single, one circuited one. I don't know, maybe you can say first single, second circuited. I think it will be, I think, easier for in the future to identify that cases. And this one can basically be first circuited, second single, both circuited, same, is the case when position 1 in both circuit, maybe you can say, yeah, both circuited if they're like both of them are in there, all right, and then you can say both circuited, same, which means both circuited, and this one equals to positions to circuitry indices position 2. Both circuited different is basically the reverse. Okay, so we have so basically this is the case 1, case 2, these are case 2, this is case 3 and case 4 that we have mentioned. Once we identify this, we'll just check like if both single, you're basically going to add them. Position 1 equals to latest, maybe you can latest circuitry index plus 1, position 2 plus 1. We'll let's increase this one as well here, and in the end we also want to say like, okay, we connected them, right? We have to say paired counter is 1. Number of connections, right? When you connect together the 1000 pairs of junction boxes. So that's you connected. Wait, what? 1000 pairs of junction. We connected one pair right now, right? Yeah, basically one paired. Okay, we can continue. Yeah. Latest circuitry index is increased. I think that's it. What about first single, second circuited? You're going to put this one to the circuitry connect, but the value that it will have will have the circuitry number index of the position 2. Paired counter will increase. You connected a pair. Latest circuitry index will not change. First circuited, second single, it's almost identical, except this thing, right? Both circuited same. Nothing. We don't pair them. We don't increase. We don't change the positions to circuitry indices. Yeah, basically pass here. Okay. And if both circuited different, here we are going to do this ugly thing, ugly transformation that get positions of circuitry index index 1. You can call it index 1 is this thing, index 2 is the other thing. Let's always change them, like the 2 becomes 1. Let's call it like this. I think it's okay for us. Circuitry index, like old, maybe you can call it like transform change indices. Index 2, like old index 2, new index 1. And then you'll pass the positions to circuitry indices. And once you do that, you'll be merging them together. They have the same index. Oh no, I gotta go. Start the counter for 10 minutes. And we're so deep in the solution, I gotta do this. We merge it and then we don't increase the paired counter. Or yeah, actually we increase them, we paired another one. The others, they stay the same, but these two were merged together, so we need to increase the paired counter. We don't need to change the latest circuitry index, okay? Okay, so that's all of the cases that we have. I don't see any other situation. And in the end, you don't do nothing, you just continue basically. And in the end, you'll return. Yeah, you need to check like the what do you have? You need to read the index, the distances thing. You need to check, you need to count. Basically do the same, but you'll count indices. uh, counts, then counts that sort, I think descent or like reverse true, right? We have reverse true right here. What was the... Anyways, let's sort it and take the first tree. 0, 1, 2. Yeah, these things. And then we multiply them, right? That was the... Okay. Okay, let's go step by step. As always, counts indices, accepts this thing. Um, basically position to index dictionary, and we'll return a list of integers. Yeah, I guess so. Pass, or return 3, 2, 1, 0. I don't know. Yeah, it should return 6, right? Maybe you can do 5, 9, 3, 2, 1. Yeah, something like that. And merge indices, let's say it doesn't do anything right now. Def merge indices. It has this position to index dictionary, right? And also it has something else, I believe. You shouldn't initialize it here. It should be like this. No. So yeah, something like this. Or did I do a mistake? No. Because of... yeah, okay. This is it. Positions the index. So we have the old one. It's an integer. New one. It's again an integer. Basically new index. Old index. Basically, this is, by the way, this is not a position to index. Yeah, it's an index. Sorry, group index. Merge indices will return none. It will change the things in place. Yeah, you're definitely right. You are definitely right. Line 30. Here, yeah. Of course. What's going on? Okay, okay, got it. This distance index is not being increased. We should do that at the end. Otherwise, we're not iterating over the distances, right? Merge indices has, yeah, so it will be old index and this will be the new index. Thank you for reminding me that. And this says non-type is not. Oh yeah, you're right. But you want the biggest ones, right? So you want to do -1, -2, -3. Here comes. So we have 20, 20 things here, and I don't know. I really don't know what happens here. Can we print positions to? I think I gotta give up. And the counts. 5, 3, yeah, and then you sort them. As a result, you have 1, 2, 3, 5, 9, and this is 45 times 3. Okay, yeah, naturally. Merge indices. Count indices as well. To be honest, I have to go right now. I really want to continue, but I don't want to mess up the other things. Oh my god, what was this question about? Look at this. Oh my god. Did I mess up something? Like, maybe I didn't understand something clearly and this lead to this much code. I think we're going fine. The only two methods are remaining, but I won't be able to complete that today. I'll continue tomorrow as usual. There's no urgency anyways.